Let me clear the stuff for number 15 and then we'll look at number 17. So here's my number 17. Again, I'm trying to solve a radical equation. I don't see a radical, but I see a exponent in the fraction form. That means that it is a radical. It's just in the exponent form. So let's see. We have 4z minus 1 raised to 1/5 minus 1 equals 2. The first thing I need to do is get rid of the 1 because that will help me get the radical by itself. So I add 1 to both sides, which helps me cancel this negative 1. And so now I'm left with 4z minus 1 raised to 1/5 equals 3. To get rid of this radical, I need to raise by the index. So I'm going to raise everything here by 5 because 5 is my index, and raise everything over here by 5. So what do I put inside? Well, 4z minus 1 raised to 1/5, and on this side, the right side, we have 3 raised to 5. When I do this, my radical cancels out and I'm left with 4z minus 1 equals 3 raised to 5, which last time when we did this, I think it was 243. But let's make sure that it is 243. So let's see. Clear. 3 raised to 5. It is 243. Okay. So now we have to get rid of this minus 1. We do that by adding 1 to both sides. All of this we're doing so that we can get the z, or whatever variable that we're trying to solve, by itself. That's the whole goal here. That's why we're doing this. Alright, so in case if you don't know why we're doing this, we're doing it because we want to get this z by itself. So we're trying to move everything on the other side. So what do we have left now? We have 4z equals 244. To get z by itself, we have to make one last step. We have to divide both sides by 4. When we do that, we get 61. So I see that my z is equals to 61. I'm going to do a quick check just to make sure that I got it right, because remember, you can have extraneous solutions, you can have a mistake in your solution, so let's make sure that we have everything right. Alright, so I'm going to write down what I have. I have 4z minus 1 raised to 1/5 minus 1 equals 2. I'm going to rewrite this as a radical. 4z, and we have the fifth root, 4z minus 1 minus 1 equals 2. Replace the z, which is 61, so 4 times 61 minus 1 equals 2. This gives us 244 minus 1 equals 2. This gives us the fifth root of 243 minus 1 equals 2. The fifth root of 243 we already know from here is 3. So 3 minus 1 equals 2. 3 minus 1 is 2. 2 equals 2. So that means that my solution was correct. Let me give you some time to take notes, and then we'll do number 19 together.